Known by many names and by many more people across the globe, Canadarm2 is a really big thing in space doing really important stuff. Here's it and some of the stuff it does and why that matters to the business world. Though it currently resides more than 400 kilometers above the Earth, performing repairs, maintenance, and resupply missions, its impact here on the Earth's surface is sizable. As with Teflon, Velcro, and freeze-dried food, the Canadarm missions were not the first to utilize their respective technologies, that is, robotic arms, but their prevalence on the world stage launched them into the limelight. Furthermore, Canadarm2 took great leaps forward in the field of robotics, and it is through these innovations that the Canadarm2 has made it back to Earth. Companies such as Synaptive Medical Inc. are utilizing the technologies developed for the mobile servicing system in their Modus 5 robotic surgical microscope. Without the development of the mobile servicing system, or Canadarm2, the technology would not exist to be able to create a fully automated surgical robot. As such, any financial entity with a stake in the surgical or medical industry would be prudent to take note of Canadarm2 and the technological advances that it has brought on. Canadarm2's reach doesn't end with surgery, however. The same or similar techniques can even be applied to hazardous environments here on Earth. Robotic arms have applications in the field of waste management, maintenance in hazardous environments, nuclear power, and much more. One prime example of this is the company McDonald Detweiler & Associates Limited, the company which created the first mobile servicing station, who have created a similar arm to be utilized in the analysis of underground radioactive waste. Space exploration most always begets the advent of new, innovative, and versatile technologies. The Canadarm missions are a prime example of technologies developed for space use that have almost immediately seen practical applications here on Earth. With so many examples of Canadarm technology already being implemented in a wide variety of fields, we shouldn't ask ourselves, why should the business world care? But instead, we must ask ourselves, how could they not? Though commonly known as Canadarm2, the official name for the robotic marvel is the Mobile Servicing System, or MMS, and currently resides aboard the International Space Station. Canadarm2, or the MMS, is comprised of three main components. The Space Station Remote Manipulator Systems, being the actual component nicknamed Canadarm2, the Mobile Servicing Base System, and Dexter, or the Canada Hand. The 17.6 meter long arm helps with assembly and maintenance aboard the ISS and weighs 1,800 kilograms. One key feature of the arm is its ability to self-relocate, meaning that it can move itself end to end across the International Space Station unaided by external forces. Firstly and foremost, the robotic arm needed to be capable of manipulating itself in a variety of ways. In fact, Canadarm2 has 7 points of articulation, each with 270 degrees of rotation, totaling 540 degrees of rotation. That's more than 360 degrees. Seeing as it is impossible for a robot to experience somatosensation, the engineers designing this flagship for the Canadian space sector would need to find an alternative method for relaying and interpreting physical contact with the arm. Their ingenious solution was a complex array of force moment sensors as well as an automatic collision avoidance system. Despite having an impressive array of sensors, Canadarm2 would essentially be Helen Keller in space without its 4 cameras, which allowed the arm to see in perfect color. In addition to its necessity to be repaired while in orbit, the arm needed to be capable of handling and manipulating payloads of up to 116,000 kilograms. Despite this, in an Earth gravity environment, the arm would be incapable of lifting even its own weight. Lastly, but certainly not least importantly, it is imperative that the arm be able to be directly attached to the International Space Station, which it was by Chris Hadfield and Scott Perenansinski on the 22nd of April 2001, securing its place in Canadian and international history. When Canadarm2 was in its infancy, people from all walks of life came together to work on it, such as engineers, non-commercial space firms, and astronauts. Okay, maybe not all walks of life, but you get the idea. After its invention, the Canadarm inspired new technologies and brought many developments. This space mission influenced and affected many. It gave jobs to engineers, manufacturers, it made space firms invest in the robotic space arm, it revolutionized surgeries, allowing doctors to perform more accurate and more precise operations on patients, and it gave scientists tools to manipulate hazardous materials, making sure nothing falls out of space onto our heads. That's staying in the video, and so is this. Good job, Alvin. Some very important benefits that were a result of the development of Canadarm2 are that it creates a safer environment for astronauts aboard the International Space Station by allowing them to complete more advanced procedures and maintenance missions from inside the safety of the ISS. It also made cosmic catches possible, which allow for frequent trips back and forth to the ISS by catching incoming spacecraft and carrying supplies for astronauts and attaching them to the main body of the International Space Station. An amazing output that was a direct result of the Canadarm2 project was the inspiration of robotic surgical machinery like Modus 5, NeuroArm, and IGAR, or Image-Guided Autonomous Robot, which are various tools that are now used to aid complete, very precise surgical procedures. As with all great things in life, the cost of Canadarm2 was enormous. This is not the cost of having a child, where the price is paid in personal sacrifices. This is not the cost of a war, where the price is paid with the lives of your friends, families, and loved ones. This is the cost of a space mission, and its statistics are a little bit more sterile. In fact, the mission cost $1.4 billion. Now, this $1.4 billion was not paid all at once. In fact, it took over 20 years, from 1984 at the conception of Canadarm1 to achieve this amount. And on that time scale, though it seems like such a large amount of money and is personally unimaginable, it's a price that I'm willing to pay for the betterment of mankind. In 1986, Canadarm2's concept had seen the light of day, and by the end of 2001, it was built, tested, and was ready to begin its journey. Canadarm2's journey began when it was launched into low Earth orbit on the 19th of April 2001, and it is currently still orbiting there, high above us and going strong. On April 28, 2001, this robotic arm completed the first ever robotic space handshake in human history, or more aptly, in robot history. It also took part in multiple space operations. In June of 2002, Canadarm2 attached itself to the MBS, or Mobile Base System, which stays on top of the mobile transporter, giving it a base platform and the ability to traverse the space station. Fast forward 8 years, and it helped with birthing the mini research module to the station. 2011 was the year our robotic arm got an upgrade. This upgrade was the boom assembly. With this, it was granted the capability to extend its reach further than ever before. In 2016, it contributes to capturing the Cygnus 7. Other than that, it kept moving and passing pallets and repairing stations, and is still working hard to this day. Canadarm2 was launched to the International Space Station in 2001, and thus the hardware and some software is from 2001 as well. This causes a risk, as the same arm is up there today. Back in 2001, the arm software malfunctioned, causing delays due to a safety breach. Another risk is the backup software to the arm. A golden rule of spaceflight is that missions cannot proceed unless the equipment has both a primary system and a redundant backup in working condition. In 2001, there was a problem with the backup system, and they tried to override the problem by sending in new computer codes. But they were unsuccessful in this endeavor. Canadarm2 uses its latching end effectors, LEE, to connect to the mobile base system and Dexter, and to perform other functions needed by the robotic hand. Because Canadarm2's hands are used quite often, they have more wear and tear than the one on Dexter and mobile base system, so the LEE had to be replaced quite often. Other risks included the system not reaching its final destination due to many different types of failures along the way. Furthermore, it could have been damaged while in space, preventing it from being able to dock.